All right. Thank you, Lauren, and thank you, everybody, for being here today. So did you know that 3 weeks of bed rest, whether it's a pregnant woman who's on bed rest, 3 weeks of bed rest corresponds to 30 years of cardiovascular aging. So that means if you are a healthy 40-year-old and you are placed on bed rest for 3 weeks, you now have the cardiac function of a 70-year-old. I want you guys to keep that in mind as we start talking today. So my lab, as Lauren mentioned, is really interested in adipose tissue, or fat. And when we talk about fat, we usually think about fat as a bad player, right? So we think about the stomach, which is functioning to digest food so it can become energy. We think about the heart, which is taking that energy to pump his blood. We think about the liver, which is then taking your blood and filtering it. And when we think about the fat, we usually think about something that's trying to actively sabotage everything that you're trying to do. So one of the main focuses of our lab is to try to figure out how to make that fat healthier. So when we talk about fat in humans, we talk usually about two different depots. You have brown fat, or brown adipose tissue, and white fat, or white adipose tissue. So brown adipose tissue is found in the cervical, supraclavicular, and paravertebral regions. So really kind of right up around your neck and then in between your spine. This is the adipose tissue that's considered a good fat. It's involved in energy expenditure. You also have white fat, which is found in your subcutaneous areas, so right underneath your skin. It's found in your intra-abdominal depots, so underneath your belly, okay, and around your internal organs, as well as some other locations throughout the body. When we think about white fat, this fat's typically involved in energy storage. And my lab is really interested in exercise. When we talk about some of the beneficial effects of exercise, we think about how exercise can combat cardiovascular disease, cognitive decline, obesity, cancer, and type 2 diabetes. And we also think about how it can promote health span, longevity, and resilience. Sorry. So one of the questions my lab wanted to ask was, how does exercise affect your brown adipose tissue? To do this, one of the things that we did was we took a group of male subjects. They were a wide range in age 24 to 90. And we took their blood before exercise and then immediately after an acute bout of exercise. And we measured these things in the blood called signaling lipids. And these are little molecules that kind of talk from one tissue to the other. And what we found is, if you look at that top right quadrant, we found one lipid that was really significantly increased in response to exercise in all of these subjects. Again, that age range from 24 to 90. And that lipid was 12-13-dihome. So we're really excited about these data. And we went on to show that exercise caused brown adipose tissue, to release 12-13-dihome, which had an effect to improve skeletal muscle metabolism and then improve cardiovascular function. So it was a direct effect on the heart. So we're really interested in these data. But one of our questions is, how do we confer these beneficial effects of exercise to those who cannot exercise? And by that, well, I do also mean those who choose not to exercise. We're really focused on the people who can't exercise, who are in bed rest or have limited mobility for some reason. And so one of the questions we wanted to ask with Daniel Gallo-Perez was if we could increase this lipid 12-13-dihome, and in the absence of exercise, could that promote health? So one of the things that's really tricky about these oxylipins is that they're metabolized really quickly. So they're broken down within 4 to 7 minutes of entering your bloodstream. So that means that you can't inject it into a mouse or into a human. It means you can't put it in a pill and take it into a pill. So we started talking with Daniel, and Daniel had developed this technology called tissue nanotransfection, or TNT. And what this means is that he can take your gene of interest, in our case, these were the genes that make 12-13-dihome, and he puts it in a plasmid, and he essentially zaps it through your skin. So now we're using the skin as a conduit to produce 12-13-dihome. And the idea was that it would increase 12-13-dihome into the circulation. So I'm just going to summarize some of the data. But what we found was that this increase, I lost one of them, this increase in 12-13-dihome, it reduced obesity in this mouse model. It improved skeletal muscle function. It improved cardiovascular function. And most importantly, it completely negated the effects of cardiovascular aging in this animal model. So our hope is that we can take these data, continue to develop these technologies into making your adipose tissue healthier, and that this healthier adipose tissue will help combat cardiovascular and metabolic disease and really help people who are not able to exercise be able to receive the beneficial effects of exercise. So thank you very much.